cat, then it has 4 paws, right? Actually, it has only 1 paw and 1 maw. You're welcome. 4 paws. Okay?
Wait, what?
I almost made Joel spill water on his table. That's going on my channel. Okay, so
I mean, no.
here's the difference between inductive and deductive. Inductive is you observe things, you observe a pattern, and then you make a guess on what you conclude. So for example, this cats and 4 paws. What have you observed in your life in terms of cats and their paws? Have any of you ever seen a cat without 4 paws?
Yes.
Okay. So ignoring you guys, most of you have not. So what you see is every cat you've seen has 4 paws. You're like, so I'm going to make a conjecture that all cats have 4 paws because every cat I've seen, I've noticed a pattern, they always have 4 paws. Unless you're Leif and you harm cats for a living, then you might have one with 1 or 2
I don't
paws.
harm cats. I had a cat and then died.
Because you harmed it.
I know.
I got a cat that died. What it has to do with 4 paws, I have no idea, right? Versus, you do this instead. The genetic code of felines dictate that felines have 4 paws.
That was the same thing.
Cats are felines. Thus, we can conclude what?
They have 4 paws.
That cats have 4 paws. So you use laws of logic and reasoning, definitions and such to arrive at your conclusion. That's the difference between inductive and deductive in just a little brief nutshell. All right? So it's how you think about things and how you arrive at answers. So let's look here. Here's your first definition. And I would say there are notes to be taken, and of course it's being recorded, so it's there as well. A conjecture is an unproven statement that is based on observations. You use inductive reasoning when you find a pattern in specific cases and then write a conjecture for the general case. By the way, if you can do this quietly and quickly, I should have already told you, please, to get a whiteboard, okay, while we're talking about this. And maybe get for your partner so we aren't all getting up together. Maybe grab 2 or 3 and divide and conquer. Okay? So we look here, describing a visual pattern. So we have this pattern, these 3 consecutive figures. And we see if we can make a conjecture about these to determine what we think figure 4 would look like. So as you look at this, I'll pause for a moment. You guys have probably already determined what you think the next figure is going to look like. But there are a fair number of different patterns to note here. There's at least 3 things to note patterns-wise. Somebody give me one pattern you notice here. What's one pattern, Dylan?
All of the shapes are circles.
Okay, so now I'm going to say there's 4 patterns to note. So you've noted the overall shape doesn't change, right? The defining, biggest shape is a circle. Great. How about another pattern here, Chris?
Like 2 shapes get added every time.
Say again?
Like 2 shapes get added every time.
Okay, so it gets to, so 2 more divisions occur every time. Okay, so far we would expect the 4th figure to be a circle, and then based on your conjecture or your notice of that pattern, Chris, how many different divisions will there be in the next one? 8. Lee, did you have another one to offer?
The shade in the area stays in the same spot each time.
What is the spot that it stays in?
Like the top left.
The top left, right? The furthest top and the furthest left it can be. Okay, so we would expect that to be the same thing for that 8 square item. Yes?
There's always like one part of the figure shaded.
There's always one, okay, that's fine. That's actually slightly different than what that was. The shaded part, we actually would note this first. One part is shaded all the time.
Yeah, only one.
And that part that's shaded is in the top left, okay? There might be one more division, or one thing we might note here as far as a pattern. Anything you can tell that we've missed? Leif?
The next figure will be labeled figure 4.
Okay. I'm ignoring. It's true. I was ignoring that pattern. Kayla?
The figure will stay a circle.
The figure, we have that already. We already know it was a circle. The one I'm arriving at as well is, Micah?
It'll cut in each section of the circle will be cut in half again.
It's kind of where I'm headed, the same thought. It'll be cut in half and they will all be the same shape. It's cutting them all in equal shapes. Leif, you have another one?
Yeah.
Tell me.
The next circle will follow the patterns of the other circles.
Okay, there you go. So, as you can tell, Kayla, or I'd say Paulina Z, you wanna hold up, did you erase or do you still have your image that you drew?
I can draw it again.
No, if you already, hold it up if you, wow, that's a really lazy shading job you did there, Miss Castro.
I think you told us not to waste ink.
Hold, you're right, I appreciate that, thank you, okay? So it should be, yeah, if you hold it up, and then the one in the upper, there you go, and hold yours up for the camera, please, Sierra, put yours on camera.
Mine?
Yeah, right there, hold it to the camera, da-da, da-da, there you go, everybody knows that, all right. So let's do a couple others, I'm not gonna say anything, please look at these two
What?
and make a conjecture about the next figure for those two different patterns.
So we need to like draw the figure?
Yeah, draw the figure, the fourth figure for each of those patterns. And Ava, you're gonna need a whiteboard and a marker.
They're
Well, I guess if you wanna draw on your iPad, that's fine.
I can't see what shading.
Wait,
Wait.
conjecture is like an unproven statement based off of prior patterns.
Based on observations of patterns. Zooey, zooey,
Do we draw or write words?
draw.
What are we doing?
Draw what you think the next figure in both of these patterns is gonna look like. You've got this pattern with the stars and this pattern with these balls. So draw what the next one is. So close, ever so close, ever so close. Yeah. Okay, that's the one, yeah.
Oh,
Yes, yes, yes.
Yeah.
So close, Paulina.
Looking past.
No, AJ, you're probably too far back to notice the shape. Savion, that is a seriously disfigured star, but it's correct. Yes, 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 Ryan. Yes, Joel. Yes, Paulina. No. Yes. Yes.
What?
Up higher, Jaden, I can't see. No, Jaden. Oh, wait, let me hold it up again, Jaden. Let me see the other one. I think the bottom one's right, but the star isn't. That's, well, there's the correct. So if you notice with the star,
I like it.
okay, every time a star is drawn, one less of the spires is shaded, right? And it goes in a particular order. We have all four here, then we're down to these three, then we're down to these two, so the next one should be down to this one. Some of you left this one here, but it's going in a counterclockwise rotation, so it needs to be left with that one. Get a board if you want, if you'd be so kind, Caleb.
Is that double?
Yeah, and then with the balls here, we start with one, and our second one has two, our third one has three, so our fourth one should have a row of four. Not hard, right? Not hard to understand. Freshman. Let's try this one.
She's not freshman.
Numbers such as 3, 4, and 5 are called consecutive integers. Make and test a conjecture about the sum of any three consecutive integers. I'm going to move over to the board while you're doing this. Okay? Let's get over, please. Okay? Make and test a conjecture about the sum of any three consecutive integers. Go ahead and do that now. Test it. Give you a moment. Are you struggling when it means to test it?
What it,
Could you give me Sierra, give me an example of three consecutive integers?
so it can be any, it doesn't have to be those three. Oh, this one.
The sum of three consecutive integers. You gave me the sum of two numbers. But again, you're supposed to be making a conjecture. So Leif has a conjecture. It'll equal the first two multiplied together. That's Leif's conjecture. Okay? The sum of any three is even. Okay, there's a conjecture. Any other conjectures?
Oh, that's not right.
Using fingers.
Let's try to count.
I like it.
Good.
Yes, I mean, guys, you know, you should be going, you just take 3 in a row and add them up. All right, so 1 plus 2 plus 3 is 6. What's your conjecture, Micah?
1 plus 2 plus 3 is 6.
That's not a conjecture, that's a fact.
1, 2, and 3 have the sum of 6.
No. When the number starts on an even number, the number will be even. Well, I know, but let's think something different.
No, wait,
Jonathan,
on, sorry.
When you divide it by 3, you get the middle number.
when you divide by
3.
when you divide by 3, you get the middle number. Okay? Well, that's a possible.
That's
Okay,
true.
so that works for this. 6 divided by 3 is 2. Let's see if that is true for, let's find another option. We started with an odd number. Now, when you're going to test conjectures mathematically, choose things that change your configuration. If you change, if I start with all odd numbers, for instance, I may get a conjecture that's not true because that's not how things work. Also, they're integers. What do we know about integers? What are integers?
Whole numbers?
They're any non-decimal number. So we ought to also, though, make sure we test what when we test it?
Negatives.
Negatives. Okay? So let's try where we start with
Negative 4,
an
negative 5.
even number, 2, 3, and 4. 2 plus 3 is 5 plus 4 is 9. So now we've ruined your conjecture, right? Because we now see it's not an even number. Okay? So yes, they're all integers. That's a lame conjecture, by the way, Leif. Okay? But we had Jonathan's conjecture, 9, he said the sum divided by 3 gives you the middle numbers. Does that still hold true in this situation? It does. All right. Let's try, I always like to start, I like to make sure I throw 0 into the mix. That's 3. 3 divided by 3 is 1. All right, then let's test the
Good
negative.
job, Jonathan.
Huh?
Nothing. I said
Okay.
good job, Jonathan.
Let's go like negative 2, negative 1, and 0 equals negative 3. When I divide by 3, do I get negative 1?
Yes.
Yeah,
Hey,
I have one.
we seem to be onto something. I think we've done enough. We've tried a variety with a good enough range that I think we've arrived at it. And you can say that conjecture either way, either direction. You could say the sum divided by 3 gives you the middle number, or the middle number times by 3 gives you the sum. Right? Either way is fine. What is it? Just read it to me, Kayla. What does it say?
When the number starts on an even number, the sum of the numbers will be odd.
Okay, well that's a whole different conjecture, but we're trying to make a conjecture about all cases.
I have a really good conjecture.
Okay, when you
I have a
add,
really
because
good
it says about the sum of any 3. It doesn't say about 3 that start with an on. Okay, it's any 3. So we're trying to make a conjecture that fits all of them. Increases by 3 each. Okay, well that's very specific. We're talking about any 3.
Yeah,
All right.
no, I mean like the
All right,
set
we've
one,
arrived at the conjecture we needed to arrive at. That's the bottom line. Okay.
one like 1, 2, 3 is that's 6. 2, 3, 4 is 9. 4, 5, 6 is 12. 5, 6, 7 is 15. Each sum is increased by 3.
You had 3, 4, 5.
Imagine that, because each number you add 1 to each of those numbers every time, and so that's adding 3 each time.
I know.
Hey, there you go. Okay, Dylan.
Does this mean that the sum would never be 0?
Can you think of any time where the sum would be 0? Dylan?
Negative 1.
Let Dylan come up with the answer. What?
They got the answer, yeah.
Negative 1, 0, and 1 equals 0, and 0 divided by 3 is the middle number of 0. Okay? All right. And here it is, testing your conjecture with other numbers, and we've come up with that. Now, to show that a conjecture is true, you must show that it is true for all cases. You can show that a conjecture is false by finding just one counterexample. And so a counterexample is a specific case for which the conjecture is false. That's another vocab term that you need to know, counterexample. So Leif had our counterexample for the cats with 4 paws, apparently. Are you telling me you had a 3-legged cat at one time? Is that right, Leif?
Yeah.
And he still was a cat?
Yeah.
You sure he was a cat?
No, he was a 3-legged cat. It's different.
He was a 3-legged cat. Was it his back leg or his front leg?
No.
Oh, but you don't remember
It was
that.
his front leg.
Or are you making this whole story up?
No, I think his front leg.
You think it was his front leg?
I've
Okay.
had a 3-legged cat before.
You what now?
I've had a 3-legged cat.
You've had a 3-legged cat?
Petted one.
You've petted one.
Yeah.
I see. And did he scratch you with his little... Oh, wait.
It was really nice.
He has
You're
other
so
legs.
cruel.
That was
horrible.
So cruel. All right.
I'm unsubscribing to that.
I deserve that. All right.
Let's cancel them with
Finding a counterexample.
Just like.
A student makes the following conjecture about the sum of two numbers. Find a counterexample to disprove this conjecture. The sum of two numbers is always more than the greater number.
Wait.
See if you can find, okay, the sum of two numbers is always more than the greater number. See if you can find a counterexample. Let's pause. Some of you already know it. I'm just giving everybody a chance
Do
to
they have to be
figure
in
that.
order? Like,
Nope, the sum of any two numbers is always more than the greater number. Micah, since you raised your hand, yes.
Yeah, if the smaller number is a negative.
If the smaller number is a negative, right? That is correct. All right, if you have a negative number in the mix, you found a counterexample. And honestly, there's an infinite number of
yeah, like
counterexamples
negative 2 plus 4.
in that terrible
Negative 4 plus 1.
conjecture. Okay? You get the idea. All right, so let's do this. Monitoring progress.
Yeah.
Okay? Make and test, okay, you've got 4, 5, 6, and 7. Let's go ahead and test those, follow the directions for those, okay?
The sign?
What's a sign?
Oh, like negative or positive?
Yes, negative or positive.
Wait.
Oh.
They're all negatives?
Product.
Okay.
Hey,
Oh, it's still.
that's okay, you just tried it. It's more about just trying. All I have going through my head right now is the
Finish it.
the finish name. Yes, the finish name.
I don't even get.
Very gory.
I mean, I know Finnish is like Scandinavian, but.
Right.
Finish him. Like,
Do you know the
Finish
Oh,
video
him.
game?
oh, finish him. Oh,
Mortal
okay.
Kombat.
Oh, like Finnish, the language?
yes.
I was so confused.
Like the Scandinavian country, Finland, yes?
I thought it was like a finishing him, like to close out the service. I was so confused.
I thought it was
to kill him.
Exactly. That's the joke.
That's the joke.
Like finish,
Oh
like
my
kill him.
goodness.
Half of us
The-
didn't
the
get the
best part of the
finish
joke is
part,
explaining
half
it
of
now,
us
isn't
didn't
it?
get the finishing part.
No, not really.
Yeah, I also thought about
I
that.
don't get the first one, so.
Make a test conjecture about the sign of the product of any three negative. Isn't there conjecture? Oh no.
I mean, the conjecture for the first one should be pretty simple, right?
Yes.
If you multiply any three negative integers, what's the sign gonna be?
Negative.
Negative. Has anybody found or wanna offer a counter example? Is there a counter example to that?
No, there is no.
Jonathan, you have a counter example?
I,
Huh? 5?
I.
Oh, we're not bringing in imaginary numbers into this, right? We're working in the real right now. Okay? It's always negative. Make a test, a conjecture about the sum of any 5 consecutive integers. Okay? 5. Do you have a conjecture, Sierra?
I think so.
What do you think?
Argued it always ends with like a multiple.
It's always a multiple of 5. Here, rather than me rewriting it, let me kind of.
Oh! Wait, so then if you
So
have-
1 plus 2 plus 3 plus 4 plus 5, if I check her math, is 15, right? 6, 7, 8, 9, and 10, 19, 27, 34, 40. And then 3, 4, 5, 6, 7, 12, 18, 25, then 4, 5, 6, 7, 8, 15, 26, 30. Okay, the only one, now again, I want to add, let's make sure negatives. I'm going to do a negative across 0. Negative 3, negative 2, negative 1, 0, and 1. Jumpy little thing. Negative 5, negative 6, negative 5. So
No,
you-
27, is it? 2, 3, 4, 5, 6, 7.
Let's see.
Oh, that's
He
six,
said
never
2,
mind.
3, 4, 5, 6, 7.
Never mind,
That
never
would be
mind.
6
Yeah,
consecutive
never mind.
integers
Never
rather than
mind.
5. Other than that, you did great, Lee.
I know, thank you.
Chris?
Kind of similar to the last one, if you divide it by 5, you get the middle number.
If you divide it by 5, you get the middle number.
That's what I said.
Let me see. So we said this added up to -5, right? Divide by 5, you get the middle number. Yeah, it's kind of the same thing. Either one is a satisfactory conjecture. Okay, great.
Great.
Find a counterexample to show that the conjecture is false. So the first one here, the value of x squared is always greater than the value of x. Ryan, you have a counterexample to that?
1 squared.
What's that?
1 squared.
1 squared, because 1 squared is
1.
1. Absolutely correct. Is there another counterexample, Micah?
Any decimal number?
Any decimal number, because it doesn't say integer, right? You're
Yeah.
correct. Anytime you square a decimal, what happens to the result?
It gets smaller.
It gets smaller. Right? Excellent job. And 0. I would throw 0 out there as well. Right? 0 squared is 0.
How do
Yes.
you, like, what would you write? Like, if that were a question on a test,
You
how
just
would
have to write, you give me just, find a counterexample, and so you would write the number 1.
Just write 1.
Yeah, say the number 1. Or you might say 1 because, or you might, if you want to explain it, because 1 squared equals 1.
That's it.
It's a little more
Or the
elaborate.
top one, you just say, like,
Well, you make your conjecture. I should see your work, I should see, you know, where you wrote out some examples to figure out your conjecture, and I should then write out what your conjecture is. Number 2, the sum of two numbers is always greater than their difference. The sum of two numbers. Ms. Castro, you have,
This would be false, like
give me a counterexample.
when you like add two negative numbers, like
Okay, let's see, so when we add two negative numbers, what do you want me to do? Which ones?
so -2 and -4. If you add
Alright,
those,
so -2 and -4, which is what?
-6.
-6 versus their difference, which is
2.
2, right? And so right there we already have the sum of two numbers is always greater. Absolutely it is not. Great, perfect. Once you find one counterexample, you're done. Okay, that's all it asks for is to find a counterexample, and you did so. All right, back to, I wait to get my board hung up hopefully today, so I can get my classroom back around. You all that weren't here on Friday missed the new layout that everybody hates. Right, we're gonna be facing that direction.
why did I not like that?
That's the way I
It's
wanted it from the
disgusting.
beginning.
Why?
It's terrible.
It's awesome.
It's like the number of people.
All right, let's get into deductive reasoning.
What time is
See,
it?
what's inductive reasoning?
Deductive reasoning uses facts, definitions, and accepted properties in the laws of logic to
Yes, I like
form
that.
a logical argument. This is different from inductive reasoning, which uses specific examples and patterns. Okay, so here you're using definitions, laws, and accepted properties, scientific facts, to arrive at conclusions versus observations. Okay? There's two laws of logic you need to know right here. The one is called the law of detachment. Okay? If the hypothesis of a true conditional statement is true, then the conclusion is also true. And we'll get into some examples of that to understand. Right now, I know you're going to look at it and go, I don't know what it's telling me. When we get into examples, it'll make more sense. And then the law of, anybody want to take a stab? How do you say that word?
Syllogism.
Syllogism is the word, syllogism. Okay, the law of syllogism. If hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. And if those two statements are true, then if hypothesis P, then conclusion R. Okay, and again, right now it's just defining it. When you see examples, it will make more sense. Okay? So using the law of detachment. So here we have this statement. If two segments have the same length, then they are congruent. You know that BC equals XY. Using the law of detachment, what statement can you make? So we have this statement. If two statements have the same length, they are congruent. Is that a true statement?
Yes.
If two segments have the same length, they're congruent. Yes, that's true. We are told that BC equals XY. They have the same length, so then we can conclude what about those segments?
They're congruent.
They are congruent. Okay? So if your conditional statement is true, then you can make the conclusion of something like this. Okay? And then the law of syllogism. If possible, use the law of syllogism to write a new conditional statement that follows from these pair of true statements. So I'll zoom in a little bit. If x squared is greater than 25, then x squared is greater than 20.
Yes.
Okay, that's a true statement. If x is greater than 5, then x squared is greater than 25.
Well,
True.
That's also true. If x is greater than 5, then anything squared is going to be greater than 25.
Oh, because 5, okay, good.
So, what is our conclusion we can derive at using the law of syllogism? And you want to take a stab at it? Emma?
Wait, to say like the whole conditional statement?
Just state what is our conditional statement then? Based on those, you have this and you have this, then we can conclude what?
If x is greater than 5, then x squared is greater than 20.
That is correct. All right? If x is greater than 5, then x is greater than 20.
The x
Or x squared is greater than 20, sorry. If x is greater than 5, then x squared is greater than 20. Because we know from the first statement, if x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then it's greater than, x squared is greater than 25. So then, if x is greater than 5, x squared is greater than 20. Now look at this one. Let's confuse the matter, shall we? If a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all of its sides are congruent. Can we conclude anything with that? Micah, what do you want to say?
If all the interior angles in a polygon are congruent, then all of its sides are congruent.
Well, we can't put those two together based on what this statement is, because they aren't connected to one. All right? Notice the law of syllogism back up here. You've got P to Q, so then the conclusion of the first statement becomes the hypothesis of the second statement to make it the next conclusion. And this one had the same hypothesis for both statements. Hypothesis P, if a polygon is regular. It did not change that. It stayed the same. So you cannot conclude anything based on that statement. Kayla? What it should have said is, if the interior of a polygon is congruent, then all of its sides are congruent. Then you could go back and say, well, then if a polygon is regular, then all of its sides are congruent. Okay, it missed that step. Because you should have had, in order to follow the law of syllogism, this conclusion, get to sit still, this conclusion should have then become your next hypothesis for the next statement. Okay, that's how that works for the law of syllogism. If the first statement is stated, if it's true, then the conclusion for that first statement then becomes the hypothesis of the next statement. Our last thing we're going to get into before we run out of time, which the bell will probably ring, but hang tight. And there it is. Just try number 8 and number 9 really quick. Number 8 and number 9. Number 8 is going to seem like almost obvious. Why do I have to state it? But you're using the laws of logic to state what it is. Using the law of detachment, what would you state?
What's the law of detachment?
The law of detachment. Anybody want to take a stab at number 8? What do you think you say with number 8? So, Michael has it correct. Look, we have our first statement. If 90 degrees is less than the measure of angle R is less than 180 degrees, then R is obtuse. The measure of angle R is 155 degrees. So what can we conclude about angle R? Then angle R is obtuse.
That's the answer.
Okay, that's the answer.
Okay.
Okay. If the measure of angle R is 155, then it is obtuse. All right. Number 9 for the law of syllogism. If you get an A on your math test, then you can go to the movies. So our conclusion there is then you can go to the movies, right?
No.
That becomes the hypothesis of our next statement. If you go to the movies, then you can watch your favorite actor. So what is our concluding statement, Paulina?
I don't know if this is right, but if you get an A on your math test and you
That is correct.
Oh.
Okay, if you get an A on your math test, then you can watch your favorite actor. See how you draw those conclusions. Thank you.